Hey everyone, it's Laz from Adatis, and today we'll be kicking off the first video of a three-part series. In each video, we'll be exploring 3 Power BI performance tips. So we've all been there before. Sluggish reports, long refresh times, Power BI datasets consuming too much memory. So with that said, let's look at the first 3 tips that should help you see better overall performance. Now the first tip is simple, yet is commonly avoided. We load more data than needed in Power BI. However, as a solution starts to grow, this can have an impact on performance. So before we ingest any data into Power BI, we should ask ourselves 2 questions. Will these columns and rows help us in the analysis of our data? And also, will these columns and rows be used to derive any DAX calculations or to establish any relationships? If no, then let's go ahead and remove this. Let's not load this data into Power BI. We want our tables to have less columns and less rows. Now, what I commonly find are Power BI solutions passed over from one person in the business to another, and what happens, more and more data is being added to it to try and answer the current business question. So let's find all these columns and rows that were historically added and no longer needed and remove them. So let's go ahead and see this in action.
We are now in Power BI Desktop, and you can see I have already ingested data and created my model using the AdventureWorks database. And through this model, I will need to analyze this year's data with the previous year's data. So in other words, we need the last 2 years worth of data. But if I drag in the calendar year and view that with our sales, notice we have 5 years of data being returned, and this is not needed in this solution. The latest data is 2014, the previous year 2013, so we can go ahead and remove 2012, 11, and 10.
Even if you think you may need it at a later stage, let's remove it for now. And if it's genuinely needed later, add it then.
But before I remove these, let's use DAX Studio to see how much memory is being consumed now and how this will change after removing these rows. So to use DAX Studio, I'm going to go to my external tools and click DAX Studio from here. And what that does, it establishes a connection directly to the PBIX file that we have open. From here, I'm going to click Advanced and View Metrics. And if you haven't used this before, I'd highly recommend it. It gives us all the metrics that we have available in the Vertipack Analyzer, and it's a really helpful tool to understand our memory consumption. So we can see currently our model is consuming 92.83 megabytes. So now if we go back to Power BI Desktop and remove these rows, so the way we're going to do that is we're going to go to Transform Data or Power Query. And now that we selected Power Query, we're going to go to Fact Internet Sales. From here, we're going to go to our order dates. And then we're going to apply a filter. So we want to only view days between 2013 and 2014. So we could go ahead and select the first day of 2013 and the last day of 2014. But for simplicity, I've created these 2 parameters before. So you can see 01/01/2013 and 31/12/2014. So we're just going to use these here to filter the rows that we need. Okay, so now we only have 2 years of data in our fact, but we also want to only keep 2 years of data in dim date. So we're going to do the same thing here, but this time, as the date column here is a data type and not a date time, we cannot use parameters, but that's fine. We can simply go ahead and just select the days. So let's go ahead and do that. Okay, so we now also have 2 years of data in dim date as well. So I'm going to go ahead and click Close and Apply. And we should have our model now refreshing, so applying those changes. And we can see that we now only have 2 years being displayed back to us. So let's go back into DAX Studio once again and see if we have saved any memory. So we're going to jump back into DAX Studio And then what I'm going to do, I'm going to click New, establish a connection to the existing Power BI file we have open, back to View Metrics, Summary, and you can see instantly we have reduced the memory consumption.
Now that was rows, but it's worth mentioning that Power BI works through the VertiPack engine, which is a columnar storage engine, therefore compresses columns. For this reason, we should be more conscious about the number of columns we are ingesting over the number of rows. Now through this same model, we will want to analyze our data in various ways, but all will be in English, so we don't need any descriptive columns which are in different languages. And you'll notice that we have a fair number of these columns. So if we go to dim product and we go to choose columns just to get the list of columns that we have available, you'll notice that we have the product name in English, Spanish, French, and then various other descriptive columns are in different languages as well. So with that said, since we're not going to be using them, let's go ahead and remove them. Now that we've removed them, we can go ahead and click Close and Apply to apply these changes to the underlying model. Now that's been refreshed, now we can go back to DAX Studio so we can see if we had a further reduction in the model size. So we're going to go back to DAX Studio. So before it was 19.98 megabytes. So I'm simply going to go ahead and select New, select our model, retail analysis, click Connect, View Metrics, Summary, and there you go. We can now see we had a much larger decrease in the total size. So we can see by only removing some rows and by removing some columns, we can actually go ahead and reduce the overall memory consumption. And when working with much larger solutions, the decrease will of course be much more beneficial. The second tip is to remove the auto date time tables. So what are these? Any date columns that are ingested or derived in Power Query and loaded into the Power BI model, a date table is auto-generated in the background. Now, the reason for these date tables being produced is to support time intelligent functions and reporting, but also to offer the capability of maybe filtering and drilling through the date attributes such as year, quarter, month, and day. Now, these are not visible directly in Power BI desktop, so it's easy to miss them. And of course, all these tables consume memory. Therefore, we should look to disable this feature if we are not using it. Let's go ahead and check this out.
So we are back in Power BI Desktop. Now we go ahead and look at the fields panel on the right hand side here. You'll notice that we only have the date, the dim date that we would expect to have, right? And all the other dimensions of facts that we would expect to have as well. The auto date generated tables do not appear here. And again, in order to identify if we have any of these tables, we must use a tool such as DAX Studio. So let's go ahead and establish a connection to our model through DAX Studio. And once we do that, you'll instantly notice that on the left-hand side panel here, we have all our tables, so all our dimensions and our facts, our fact table being listed. But below that, we also have these local date table being displayed here. And these are essentially all the tables that are auto-generated by Power BI. So to actually remove these, we have to go back into Power BI Desktop. So if we go back into Power BI Desktop, from here we can go ahead and select File, Options and Settings, followed by Options. And here, underneath Current File, you'll see that we have an option for Data Load. And underneath Data Load, we have Time Intelligence, Auto Date Time. So this here is currently checked, meaning Power BI will be creating these auto-generated date tables. Now, before we go ahead and disable this, just very quickly, we also have Data Load underneath Global. And you can see the same setting being displayed here. So if we go ahead and remove this from here, this will essentially mean that Power BI will not generate any of these tables in any future solutions that we start building. So anytime we open up a new PBIX file, this will essentially be unchecked. But for now, let's go back into current file, data load, and I'm going to unselect auto date time here. I'm going to click OK. Once I've clicked OK, I always like to do a refresh of the solution. And now that the solution has been refreshed, we're now going to go ahead and save it. And as you can imagine, we're going to go back into DAX Studio. And this time we would like to see if those date tables have disappeared. And yes, they have. So you can see that we no longer have those date tables being displayed here. We only have what we would expect, and those are the dimensions and facts that we ingested into the model. And apart from that, if we go to advanced and view metrics, let's see if we also had another decrease in the overall size. And we can see that we have. So previously this was 63.5 megabytes and now it's 60.5 megabytes. Again, not the largest decrease, but when we're thinking of other solutions, which are much larger in size, this can make a much larger difference. So if we aren't using these auto-generated date tables, let's go ahead and simply remove them the way we just saw now.
We have now come to tip number 3, and that is to remove high cardinality columns. So what are these high cardinality columns? Well, they are columns that have a high percentage of unique values. And the reason we do this is the compression works much less efficiently when compressing high cardinality columns. So the more unique value a column contains, the less efficient the compression will be. So let's go ahead and check this out.
So, how can we identify high cardinality columns? Well, we can do this by going to Power Query. So we go to Transform Data. And once we're in Power Query, we can simply go ahead, go to View, and enable Column Distribution. Now, this shows us the distribution of the data within the column and the counts of distinct and unique values as well. And there you have it. Now that is loaded up. So the distinct over here tells us essentially the total count of how many values exist, whilst the unique tells us how many of those values only appear once. So we can go ahead and use this here. And if you do that, also be aware that right now, this here is being based off the top 1,000 rows, right? Because that's how Power Query works. The preview is also always the top 1,000, but we can go ahead and click on based on the entire data set. But be aware, in order for this essentially to work, you can now see that the column distribution is now rendering again. Power Query must first load all the data in memory before these actually go ahead and display. So if you're working with very large data sets, this can take some time as well. So I actually prefer to use DAX Studio. So there you go. We can now see that that has appeared. But even so, I prefer to use DAX Studio for this and actually analyze high cardinality columns through the Vertipack metric. So I'm going to go ahead and close this down. And once we close that down, we're going to go to external tools. And as you probably already know, we will go ahead and establish a connection to our Power BI solution using DAX Studio. Now, once we're in here, we're going to click Advanced, View Metrics. And this is really useful because the first column that we have here is cardinality. So a good way to identify high cardinality columns. So I'm going to go ahead and sort by this. We can instantly see fact internet sales is the highest one. So let's go ahead and expand this and see if there's anything we can actually go ahead and remove or maybe convert if possible. So you can see that we have a sales order number. That makes sense to have a high cardinality, right? Because every row essentially has a unique number, but that certainly is something that we wouldn't want to remove. Customer key, also the same case, and that would be the case for all keys as well. Again, keys uniquely identify a row, so these will have a high number of unique values. But then one thing that stands out here is that we have the ship date, which is the third highest in cardinality. So with that said, we can actually go ahead and look into that. So we're going to go back into Power BI Desktop, and then we're going to go back to Power Query. And once we're in Power Query, that was in fact internet sales. So I'm going to scroll across and go ahead and look for that column. There we go. So we have ship date. And what you'll instantly see is that for ship date, we actually have not only the dates being displayed, but also the hour is displayed against that as well. So we reduced the data here to only display data for 2 years. So the maximum count of unique dates we can have is 730, right? So that's not too bad. But as part of this column here, apart from having the date, we also have the hour. So essentially, how many unique values could we have here? Well, that would be 730 multiplied by 24, as that is the total number of hours that we could have here. So rather than have 730 unique values, we could potentially have 17,000 or over 17,000 unique values. And if we also have minutes and seconds, this number of unique values will shoot up dramatically, causing the compression to work a lot less efficiently. So with that said, let's go ahead and convert this from a date time to a date. And now, if we go ahead and close and apply there, and then we're going to refresh our solution as well. Okay, let's now go back into DAX Studio. And let's have another look at the high cardinality columns once again. And you'll notice now that ship date has now been reduced to 393. And that's essentially the process we want to follow here. If we have any of these high cardinality columns, let's simply go ahead and try and reduce them, or in fact remove them if we do not need them either. And very lastly, we go back to summary now. You'll notice that the total size has decreased by a small amount. But again, the more high cardinality columns we remove, the better the compression as well.
So, those were the first 3 Power BI performance tips that can help increase our overall performance. I hope you found this useful, and I look forward to seeing you in the second part of this video series where we'll be exploring 3 more performance tips. Take care for now.